Go ahead.
Okay. So everybody, we just talked about the measurements in the schematic sense. I just want to demonstrate the equipment so that you understand how these measurements were performed so you can work with the data set. And so essentially, I'm just going to go through how we get all the numbers on this page that I'm going to be sending you. Okay? So this is the apparatus, and what we want to do is spin it, but we have to spin it at such a rate so that it is at, we know where we know what the radius of the orbit is. And so there is a little piece of tape here, right there. And on the bottom of this, there's a little nubbin. And so we're going to spin it so that hits that. And then it'll make a sound. And then I'm just going to measure the time for rotation by counting the time for 20. Now, Tyler and I can hear this, but you can. It's hitting, and so I'm practicing. And then I start and I go 0, 2, 3, 4, 5, 6, 7, and I count to 20, okay? And at the end of 20, I record the time, and then the time, that will be for trial 1, goes into the first set, and I do that 5 more times. So that's how we get the period of rotation. We measure the time for 20 rotations, and then eventually we're going to divide by 20, okay? Then I need to know the easy things, the mass of the bob. This is the bob. I'm going to just take it over and measure the mass over on the digital balance, and so that will be given to you. And then the other things I need to measure are the dimensions, right? And so first I'm going to measure the shaft diameter. Shaft diameter, I'm going to use the calipers, and I'm looking at this fat shaft. And now remember in our discussion I drew this out. So I get this diameter, right, and that's the shaft diameter, and then the distance to the tooth, I just measure it, and I'm going right to the middle. I'm assuming I can keep that bob rotating over the center, and I measure the distance. I'm measuring from the outside to the inside. Some people measure from the inside to the center, right, and it's around, if it's the outside, it's going to be over 18 centimeters, and so we'll be able to see the numbers, okay? And then the other thing I need to measure, of course, is the force that is necessary to keep this thing in its position. Now, when we're spinning it, of course, it wants to go in a straight line, and so the spring is what's bending in a circle. Here, I'm going to use a hanging mass that I hang over this pulley. And I'm going to put enough mass on there so that it comes out to the same position. And that's a little too much. Actually, that's really close right there. Too much. And when I get close, I'm going to jiggle this back and forth. And let's just say that, actually that's pretty darn good right there. Then of course I'm not just going to trust these numbers. I take this over to the digital scale and I measure the mass. And so then with the free body diagram, you can calculate the force the spring was exerting. That's the hanging mass. And then we do the calculate the speed from the radius and the period. And then we can compare those two values using the centripetal force.